Hey guys, it's lesson 17 and let's go ahead and get started with our first page. So prime factors. We are asked to fill in the missing numbers in these prime factor trees with prime factors in the circles. Then complete the prime factorization product underneath. Okay, so let's look at number 1 together. We have 12. And we are asked to find its prime factors. Okay, so 12 is a product of what two numbers? Well, we're already given 6. So we know that the other number is going to be 2, right? Because 2 times 6 equals 12. Okay, then now 6. 6 is a product of which two numbers? 2 and 3, right? Because 2 times 3 equals 6. Okay, but let's revisit what prime factorization is. Okay, well, prime factorization is a finding of which prime numbers, which prime numbers multiply together to make a original number. Okay, and then we know that a prime number is a number that is not a product of two smaller numbers. For example, like 2, 3, 5, right, 7, and so on, right? And so, is 2 and 3 a prime number? Yes, it is, right? And so that's it. There we have our numbers. So 12 equals 2 times 2 times 3. Okay? That's it. Simple and easy. Try number 2, 3, and 4 on your own, and then we will move on to our next page. So mode and range. Actually, before we get into this, let's review what mode and range is. So mode is a value that occurs most often. So a number that occurs most often. Okay, then what's range? Well, range is a difference between the largest number, and the smallest number. Okay, so we're subtracting the smallest number from the largest number. Okay, so let's look at number 1. Let's look at the set of data. Okay, here we have the set of data, and let's figure out what mode and range is. So mode. Well, we first got to count all, like, how many numbers there are, right? So how many negative 4s are there? Well, let's count. There's 1 negative 4. Okay. There's 2. Oh, there's only 2 negative 4s. How about negative 1s? There's 1. There's 2. There's 2 negative 1s. And then how about 5s? There's 1. There's only 1 5. Okay. How about 3? There's 1, 2, 3. There's 3 3s. Okay. How about 7? There's 1 7. Okay. How about 2s? There's 1, 2. Okay. There's 2 2s. 2 2s. How about 6? There's 1 6. Oh, there's a lot of numbers. How about 8? There's 1 8. 0. There are 2 zeros. Okay. How about negative 2? There's 1. Oh, there's only 1 negative 2. And then how about 4? There's only 1 4. There's 1 9. There's 1 11. And then there's 1 negative 6. And there's 1 negative 3. Okay. And so now we got to count which value occurred most often. Okay? And then which one's that? 3, right? Because it occurred 3 times, where the other numbers occurred once or twice. Okay? And so our mode is 3. Then how about our range? What's our range? Let's erase all of this. So our range, so for range, we only got to figure out 2 numbers, the largest number and then the smallest number. Okay, so what's our largest number? Well, our largest number is 11, right? And then what's our smallest number? Well, I think it is -6. Okay, and so when we subtract -6 from 11, okay, when there's two negatives, two minuses, it turns into a plus, right? And so what's 11 plus 6? 17. So 17's our range. Okay? So that's it. Try number 2, 3, and 4 on your own. Figure out the mode and range. And then let's move on to the third page. So multiplying and dividing negative numbers. Okay? So we're simply just finding the product and quotient. So number 1, we have -6 times 2. Well, we know that a negative number times a positive number is going to equal a negative number. Okay, so let's put a negative sign there. And then now we just simply do 6 times 2, which is 12. Number 2. Well, again, we have a negative number, right? But this time, it's division, okay? So a negative number divided by a positive number, a positive 5, is going to equal what? Still a negative number, right? Why? Because negative times a positive is going to equal negative. Okay? So then again, we put a negative sign. Alright, we put a negative sign. And then again, we just simply do 20 divided by 5, which is 4. Okay? So that's it. Simple and easy multiplication and division. Finish this page. And then let's move on to our last page. So number 1. A company donates 935 pencils to a school. The pencils are divided evenly, so it's divided evenly among 9 classrooms. The rest of the pencils are given to the library. How many pencils were donated to each classroom and to the library? Okay, so what are we trying to figure out here? What 2 things are we looking for? Well, since it's division, right, we are looking for the quotient. We're looking for the quotient and the remainder. Okay? Because it says the rest of the pencils were given to the library. Okay? So then the quotient is going to be representing the values, the number of pencils that were donated to each classroom, and then the remainder is going to be the number of pencils that were donated to the library. Okay? And so let's actually do the math. 935 divided by 9. Okay? So how many times does 9 go to 9? Once. 1 times 9 equals 9. Subtract. Cancels out. Okay? Bring down the 35. And so how many times does 9 go into 35? Well, 9 times 4 is 36, right? So then it must be 3. Oh, and there's a 0. Okay? So it must be 3. And so 9 times 3 equals 27. Subtract. What do you get? 8. And then does 9 go into 8? No, it doesn't. Okay, so that's it. Our remainder is 8, and our quotient is 103. So let's write it. So each classroom, so classroom, C for classroom, 103 pencils were donated, and then for library, 8 pencils. Okay, so let's look at number 2 now. So number 2, Manny owns 83 sets of basketball cards. Okay, each set has exactly 504 cards. What is the total number of basketball cards Manny owns? So what are we doing here? We are multiplying, right? Which two numbers? 83 and 504. So we're looking for the product. So let's do the math. 504 times 83. Okay, that's 12. That's 0. Oh, sorry, that's 0 plus 1. That's 1. That's 15. That's 32. 3. 40. Okay. So just add. That's 2, 3, 8, 1, and 4. Okay. And so our answer, the number of basketball cards that Manny owns is 41,832. Okay. That's it. Finish the rest. And then here's the answer key.